Okay, now we're going to talk about integration by substitution. Go on and write down this theorem. And it says, suppose I have a function g whose range is on an interval I, while function f is continuous on I. If g is differentiable on its domain, and capital F is the antiderivative, is an antiderivative of f on I, then the integral of f of g of x times the derivative of g dx is going to equal f of g of x plus c. Another way to write this is to let u equal g of x and then substitute u in. And then the integral of f of u du is f evaluated at u plus c. Now, the trick with these is you have to identify the different functions. Think of this f as your outside function. All right, and then let me change pen colors. Let's think of g as the inside function. All right, and then finally, there's this third part, which is the derivative of g. All right, let's do a problem. Sometimes the easiest way to do these is to simply do them. Suppose you have this situation right here. All right, let's undo that. Do you see if I let g equal x squared plus 1, then g prime is 2x. So I've got my derivative, and then I've got my g function. So I'm going to let this x squared be my f. So f of g of x is f of x squared plus 1, which is, now my function is basically a squared function. So this is x squared plus 1 squared. All right. So I've got f of g of x and I've got g prime. So, and you don't have to do all these steps. I'm just kind of painfully stepping it out for you. Tell you what, let me erase. Well, let me rewrite this. So the integral x squared plus 1 squared times 2x dx. All right, when I do this integral, remembering this is my derivative, this is my inside function, this is the integral of a function squared. So that's going to be my function cubed divided by 3 plus a constant. And of course my function is x squared plus 1. Now what do you do when you have trig functions? Well, you see here, let's let this right here, cosine of 5x, let's that be my outside function. And then let g of x equal 5x. So g prime is 5. So here, let me switch pen colors. Here's my g, 5 dx. All right, so what do I know the integral of cosine is? It's sine. So the integral of 5 cosine 5x dx. The integral of cosine is sine. And my argument is 5x plus my constant. Now, let's check this by taking the derivative of it. The derivative with respect to x of sine of 5x plus c is derivative of sine as cosine 5x times 5 plus 0. Lo and behold, it works. Now, let's come over here to this one right here. You don't always have a pattern to recognize. As a matter of fact, this is a constant. You know you can pull this constant out. cosine x dx. All right, and this is just a regular integral. So this is 5, integral of cosine is sine. All right, this is a constant multiple rule. Pretty much, if I have k times f of x dx, that's going to be the same thing as k times the integral of f of x dx. All right. Now, sometimes we're not so nice to you. We don't give you the derivative inside clearly. Sometimes you're going to have to multiply or divide by some sort of constant. Let's let g equal, let's do this inside, x squared plus 1. And then g prime of x is 2x. Now you see, I've got the x, but I don't have that 2. So what I'm going to do is I'm going to go and put it in there. All right? I'm going to put it in here, but I can't just double my problem here. I have to multiply by the inverse. So let me rewrite this. This becomes 1/2 the integral, and I'm going to rewrite it just a little bit so we can see the g prime. Okay. Okay, so now we have g is x squared plus 1. We have dg. And this becomes 1/2 x squared plus 1 cubed divided by 3 plus constant. So what is this? This is x squared plus 1 cubed divided by 6. Now I'm going to check this, make sure this is right. The derivative with respect to x of x squared plus 1 quantity cubed divided by 6 plus c is, let's see, 3x squared plus 1 squared times the derivative of the inside, which is 2x, divided by 6 plus 0. So let me simplify, and I get x squared plus 1 squared times x. They agree. All right, your turn. Try identifying u and f of u and du for each of the following. And you don't have to solve these. When you're done, turn off the tape.